Welcome to part 2 of the Lecture 7 Intro to Loops. What we just saw in the last part was we tried to write a program that takes any number of inputs from the user, some number specified by the user, and then outputs the average. And we ran into some problems using traditional techniques, the input, the output, the if statements, the math, wherein the solution eventually became a lot more complicated than the problem. And it's one of those things where if it takes more time, if it takes significantly more time to write software to solve a problem than it does, then that piece of software saves the user. At some point, it might just become faster for everyone to do this by paper or by hand, rather than doing any sort of software development. Fortunately, though, we have a technique called loops, or repetition structures, which we can make use of in order to make this program go from really complicated to remarkably straightforward. That's pretty exciting. And so the first loop structure that we're going to talk about is the while loop. And there are two different ways that we can run while loops. But here's what they look like first, just so you get a sense of what the syntax looks like. So we have while, and then in parentheses, some Boolean expression. And while that condition is true, we do some stuff. We have a code block, and so on. So it looks a lot like an if statement. It's just the difference between an if statement and a while loop is that with the while loop, when it gets to the end, we circle back to the beginning, and then we evaluate this condition and see if it's still true. If it is, we loop. Then we circle back to the beginning, see if it's still true, and so on and so on and so on, until the condition becomes false, at which point we skip down to the end. And then keep going. Okay? So a while loop will start with the while keyword. This is sort of like the if keyword. It's just the while keyword. From there, we have a Boolean condition. So everything between the parentheses should ultimately evaluate to either true or false. So you'll probably use the relational operators. You'll probably use the equality operators. Later, in the future, we'll write our own methods that return Boolean values. But for right now, we'll just use the relational operators, the equality operators, and maybe raw Booleans themselves, perhaps with some of the logical operators. If that condition is true, we do some stuff. If it's not true, we skip down to the very end, this closing curly brace, and we just call it good. Okay? That's while loops. And so what the while loop does is it keeps looping. When I say keeps looping, what I mean is as soon as we get to the end, we go back to the start, and then as soon as we get to the end, we go back to the start, and so on, up until the condition stops being true. Right? So as long as the condition is true, we're going to keep looping. Okay? There are two types of loops that we might write. The first is a counter-controlled loop, wherein when we have a certain number of times that we might want something to happen. And the second is a sentinel-controlled loop, wherein we keep going up until some condition is met. And so sometimes we call these definite repetition for counter-controlled and indefinite repetition for sentinel-controlled. Those are terms that you probably won't ever need to know. But the big thing is that the counter-controlled, we know how many times it's going to happen. Like maybe we don't know when we write the piece of software, but certainly our software figures it out. And with sentinel-controlled, we just wait until some condition becomes false. We wait until something happens. Okay? And as we write loops, we have our loop body, and we can do a whole bunch of things with those loop bodies. We can collect input and do output. We can do arithmetic and calculations. We can use if statements and switch statements. And we can even put, if we feel so inclined, more loops inside our loops. And this gets out of hand pretty quickly. And I'll show you later what that looks like and sort of what to watch for. But these are some examples of a couple of things that we might do. Okay. Now when we want to perform an action a certain number of times, that'll be our first step. We use counter-controlled repetition. What counter-controlled repetition basically entails is we create a counter, which is going to be an integer. And it usually starts at 0 or 1, but not always. Then we have a loop condition that keeps looping so long as the counter is within a certain range, so long as it's below some number, so long as it's above some number, something like that. We use the relational operators or the equality operators. And then we have a means by which we increase or decrease the counter each pass through the loop. So here's an example of that. Okay, we're going to create int I, which is 0, I, j, and k, and those are the names for the unit vectors in physics and in Calc 3. In programming, we use I, j, and k as stand-ins for our counters. Okay, so you have int I is equal to 0, that'll be our counter, and then while I is less than 10, we'll increment I, we'll increase it by 1 using the unary operator, and then we'll print it. That system.println I. Okay, so as we go through this, I starts at 0, I is less than 10, that's true. I becomes 1, we print 1, go back to the start, 1 is less than 10, so that's true. I becomes 2, we print 2, go back to the start, 2 is less than 10. I becomes 3, we print 3, go back to the start, 3 is less than 10, 4 is less than 10, 5 is less than 10, all the way up until we print out 10. Okay, and so when this happens, when we run this, what we'll see is using only one output statement, the numbers 1 through 10, each on their own line. Okay, so let's take a look at that. Okay, so we'll make our counter, and then while I is less than 10, we'll increase it, and then system.out that print line I. Okay, so that's not going to be too bad. That's not going to be too bad. And the big thing here is in the past, we would have had to do system.out println 1, system.out println 2, system.out println 3, and so on. We don't need to do that at all. We can just let the loop take care of everything. And right here, this is our loop body. You go from this brace all the way up. So this is going to happen every time you pass through the loop. Okay, so we'll save and quit. We'll compile. Then when we run this, we're going to see the numbers 1 through 10 appear on the screen, just like so. And again, this comes from this loop, right? As soon as we get to the end, we go back to the start and we check this condition. If that condition is still true, we loop again. Okay, so that's the very basics of the counter-controlled loop. Sometimes you'll count up, sometimes you'll count down, sometimes you will count up by 2s, up by 3s, down by 2s, down by 3s. You might count up by doubling, you might count up by tripling. There are any of a number of ways that you can make this happen. So the line between counter-controlled loop and sentinel-controlled loop is sometimes a little bit blurry. This is basically what happens. Usually you start at 0, and usually you count up until you're less than some number. Okay, but there are some problems that we might run into. In this first one, for example, we have this int I is equal to 1, and then while I is greater than or equal to 10, we use system.println I, and then I++. Okay? The problem here is that the problem here with this, right now, this loop will never enter. But let's say that we had int I is equal to 10. We come down to this while condition. So 10 is greater than or equal to 10. That would be true. We print it out. Then it becomes 11. And then we have 11 is greater than or equal to 10. That's true. We print it out. Now we have 12, 13. There's no point where that condition becomes false. We run into an infinite loop. And I want to show you real fast what that looks like. Okay, so we're going to open this back up. So here's our first loop, and then we'll say I is equal to 10. It'll already be equal to 10, but that'll be okay. And then while I is greater than or equal to 10, system.out println I, and then, oops, helps to have a semicolon, I++. Okay? And so right here, this is going to be infinite loop territory. We're going to do a pretty hard infinite loop, and this is just going to count up forever and ever and ever. And I want to show you what this looks like real fast. Okay, and you can see these numbers where it's just counting up without end. This is because, and as we see in the in this particular piece of code, our end condition, this is our loop condition, this will never become false so long as the loop enters, right? We're going to count up, but since we're counting up, there's never going to be a point where it stops being greater than or equal to 10. That isn't ever going to happen, assuming we enter our loop. If we don't enter our loop, it'll be fine, but if we enter this loop, that condition will stay true forever and ever and ever, which is a problem. So right now we're up at the 3 millions, it looks like, and counting up pretty fast. Now if you get into an infinite loop, and you will, sooner or later, you're going to run into these, the way to get out of it is just Control-C, just like so. What that actually does is it pauses the process, and there's a way to resume that, but in our case, like, we can just do Control-C, and then everything's pretty okay. And at some point, Loki will time out as well, so that'll also be alright. Okay, and what we're going to do here when we come back is we're going to modify our averages program so that it collects 10 numbers with a loop. And then once that's done, and once we have it successfully tested, we'll modify it so that our program can average any number of numbers. So we'll be back in just a second.